Welcome to Nitty Gritty Talks, and today we're gonna talk about nitty gritties of the world famous puzzle game Sudoku. I really want to enable a lot of people to start their journey with Sudoku and also other puzzle games and make it absolute beginner friendly series. The first thing I want to mention is why should you care about puzzle games? And in my opinion, it's quite important to start from early age to engage in these logical activities, to train your brain and to develop logical thinking, which is going to be really, really helpful in this world. I hope this would be interesting and fun for all. My story with Sudoku started not as long ago, which is kind of weird to me at this moment, it seems. So I actually knew about its existence for many years. And then when I met my spouse, I started to think, why don't I try my hand at Sudoku? Because she told me like I used to solve it when I was young, like spending many hours on this. And I'm like, well, I still don't know how to solve Sudoku. Like took it like a challenge and then spend my many hours in this. And I thought I could share this vision and this interest with others. I won't tell you the full story of Sudoku since it's quite long, but I want to share some interesting fragments from it just to have a feel for how this puzzle developed over the time. The first question I would like to ask is what do you think where this game originates from, where it takes its roots? Yeah, and if you thought it's Japan, it's not completely true. The person who was credited with with invention of this puzzle game is actually Leonhard Euler, and this is a really great mathematician, uh, born in Switzerland in the first half of 18th century, the inventor of the number pi, and as a hobby, he was thinking about what would happen if we take famously known puzzle from ancient China, which was called magic numbers, and we would twist some rules around. And that's how basically he created a prototype for Sudoku, which he called greko-latin squares. Since I referred to magic squares, let's learn what it is. This is a Chinese puzzle. It's been attributed different spiritual meanings, but the essence is that each row and each column in a square grid with the size n should have the same sum. So you could draw grid 3 by 3 or 4 by 4 or possibly more. And that's it basically. By saying what the sum is and removing several numbers from the grid, you would ask somebody to fill it up and thus completing the magic square. And this sum would be called magic sum. There are also interesting things like what you can try to investigate. For example, what is the minimal magic sum for the 4 by 4 grid where you are allowed to put only positive integers? Right, in this answer was discovered in 1514 to be 34. So you could investigate it, for example, going to a dedicated website, and they have Magic Square Solver and they have Magic Square Generator as well. So you could see what the different things could look like and investigate different properties of it. And what Leonard Euler was thinking of is that this is a mathematical game. So you have a sum and you need to satisfy it. And when you search for some value, you would add or subtract something and find out like that there is like 5 missing. Or even if we put it really plainly, you could make a system of equations and actually deduce whatever value each cell needs to be. But what Leonard Euler was thinking of, let's remove this sum and see what the game will look like. And what it will look like is actually a puzzle of different permutations or options, like how you can twist numbers around. And it's not mathematical puzzle anymore. It is more a logical puzzle. So in his greko-latin squares, he proposed the following rules. There are letters of Greek and Latin alphabet, one from each alphabet per cell, basically taking the first n letters from each alphabet. If the grid is 4x4, it would be the first 4 letters. And then we need basically to fill it in a way that each combination of the letters appears on the whole grid only once. It's one property. And another property that each row and each column would have each letter of each alphabet only once. So these are the rules, and they resemble Sudoku much more in this edition. There were a couple other steps in the development of the game. It started to spread in the second half of 20th century, starting from Japan, and it was called Sudoku, which means a single number. So, and it refers to the rules of the game itself, which is to have a single number in a row, in a column, and in a block. So let's start discovering classic Sudoku from the mini Sudoku version. So mini Sudoku version consists of a 6x6 grid divided into 6 2x3 blocks and contains number from 1 to 6. So our task would be to fill up this grid in order for each block, each row, and each column contain each digit only once. So let's try to solve it and investigate which rules can we use here. So the first rule, the simplest rule, is elimination. So if we see any row, column, or block missing only one number, we can immediately place it there. So let's see, in this block, 1, 2, 3, 4 is missing. So we placed the 4 here. Let's look at this row. This row has 1, 2, 3, 4, 5, so it's missing 6. We placed the 6 here. Let's look at this row, and it has everything except 5. Let's look at this block, and it has 1, 2, 3, 4, 5, 6. Let's look at this column, and it's missing 1. Is that all? The second thing that we can use is to go through all the options in a row, column, or block. Brute force. So let's see this block, which is missing 2 numbers. Will we be able to complete it? So which numbers does it miss? It misses 3 and 6. Can we place 3 or 6 here? Yes, we can place them both. Can we place 3 or 6 here? Yes, and we can place here only 3 because there is already a 6 in this column. So we place 3 and we place 6 here, the only digit left. Oh, and also I missed this column, which is missing only one digit, which is also 6. Let's use our brute force again here. So it is 3 and 4 missing. 4 is already in this row, so it has to be a 3 and a 4 here. This row, only 2. Right? Great. So basically, when we said elimination and brute force, we started from applying one of the 3 rules, either row rule or column or block rule. We have a row with 3 empty and row with 3 empty, which is kind of maybe too much for brute force. But the columns have 2, and 2 is great. It's quite manageable. So what are we missing in this column? We are missing 1 and 3. Can we place 1 and 3 here? Yes, we can. Can we place 1 and 3 here? Yes, we can. Okay, it didn't give us anything. What about this column? 1, 2, 3, and 6. Can we place 6 here? No, so we place 3 and 6 here. What about this two? 1 and 5. Can we place 5 here? No, only 1. And 5 goes here then. And then the only digit in this block left is 1, and 3 goes here. So we solve this using only our first 2 rules, elimination and brute force. One of the properties of standard Sudoku, which may not come to mind immediately, is that in place of those numbers 1 to 9 may be completely arbitrary objects or things. So, for example, if you change all ones on the grid with twos, twos with threes, threes with fours, and so on, and nines to ones, so you make a circular rotation of all the digits, it would be still a valid puzzle, or you can make substitutions in any other way so that each initial number is mapped to some other number or some other object. And one of the examples of possible interchange would be some of the board games which I saw that you actually have fruits to place on the grid, which makes it somewhat very unusual puzzle to solve, but you get used to it like within 10 or 15 minutes. So if you can place fruits on the place of numbers, you can also place letters instead of numbers. And there is a kind of Sudoku which does exactly that. And it is called Wordoku. And sometimes, as a hint for the player that the level was solved accurately, there will be a word, a 9-letter word, across the main diagonal. So here is the example showing Wordoku and the puzzle solution with Wikipedia as the solving hint taken from Wikipedia itself. Going deeper into different kinds of Sudoku, I would like to cover 2 more of the varieties. So the first one is called twin Sudoku. And the idea here is that you are given 2 grids of Sudoku, but you cannot solve one without the help from another. And the helping rule here is that it is basically the same puzzle, but all the digits have been replaced, like I was saying in the beginning. So for each digit from the first puzzle corresponds some other digit from the second puzzle and vice versa. So for example, if you see here in the 4th row and the 9th column, number 7, and in puzzle B, fourth row in the ninth column is number 4, that means everywhere where in the first puzzle is 7, the second puzzle will contain 4, and vice versa. Whatever in the second puzzle is 4, in the first will be 7. And then, discovering more and more digits in each of the puzzle, you can go into the second puzzle, solve something there, and then return to the first puzzle. So this is twin Sudoku. The other kind of Sudoku, which for me as a person who heard about it quite recently, is looks quite arbitrary. Why would you have these rules? But I guess you can have fun and explore and modify rules and see what kind of other puzzle it is and how it would affect the different strategies which are needed to solve it. So sandwich Sudoku is the kind of Sudoku which has the numbers on each row and column, and they show not the sum of the row or a column like in magic squares, but this time the sum of cells between 1 and 9. So here, for the first column, 21 is the sum between 1 and 9. So you see that there is 5 and 7 given 12, which means that 3 cells that are left will give the sum of 9. And here in the row 2, there is a sum of 0, which means that the 1 must be neighboring the 9 either from the left or from the right. But meanwhile, I think it's been enough for one quite long video about Sudoku and different varieties and history and personalities and how it can help for a person to develop, for a child to develop, and just to have fun, right? So knowing how it works, I hope you can try your hand in this interesting puzzle, which can become a hobby for some. And at the same time, I hope that you will discover some more techniques of how to solve it other than those that I mentioned in the video, and also that you will discover a technique of marking. So even in the common solvers that you can met online, there is a functionality of marking, so you can put notes in the cells. So you can try and see what kind of marking will suit you, what your notes will mean for you, and how they will help you to solve puzzles much faster and easier. And then hopefully we'll solve one other puzzle in the third video of the series, and we'll talk through how these markings work for me and how which other techniques that I use to solve intermediate level puzzles. So thank you for your time with me today, and hope to see you next time.